This video is about the equation of a circle, which you can see there, but using circle theorems. So there were 9 circle theorems that you learned in GCSE. This is a very quick recap of those 9 circle theorems. First of all, the angle at the centre, so this angle here, is twice the angle at the circumference. Second, the angle in a semicircle, so this here is the diameter, so splitting that circle in 2. The angle in a semicircle is always a right angle, always 90 degrees. Next, the angles in the same segment, so these 2 red angles there are in the same segment and they would be equal to one another. Similarly, these 2 green angles there are also in the same segment, so they would be equal to one another. The opposite angles in a cyclic quadrilateral. So a cyclic quadrilateral is a 4-sided shape where all corners, all vertices are on the circumference of a circle. That's a cyclic quadrilateral. And if you have a cyclic quadrilateral, the opposite angles will add up to 180 degrees. Next, a tangent will always be perpendicular with the radius. Next, 2 tangents from an external point will be equal in length, and they will also subtend, create the same angle between the tangents and a line to the centre. Next, the radius will always bisect, so cut in half, a chord at 90 degrees. And then finally, the angle in the segment between a tangent and a chord will be equal to the angle in the alternate segment. Right, what I will do is I will post a link to a playlist of videos from GCSE if you need a recap on any more detail of any of those. So have a look in the description, have a look at some of the videos there if you need a recap on any of those 9 circle theorems. The rest of this video is going to be using 3 of those in particular to help us do coordinate geometry with circles for A level. So the ones in particular are these 3. The angle in a semicircle is a right angle, starting with that one. So that can be useful because if I have 3 points on the circumference of a circle, let's call it A, B, C. If AB is perpendicular to BC, so if I can show those lines are perpendicular by looking at the gradients and showing the gradients multiplied to be -1, or thinking about the negative reciprocal, if I can show this is perpendicular to this, that means we have a right angle there, which allows me to say for certainty that AC is the diameter of the circle, which then allows me to find the centre of the circle very easily, and then I could find the equation of that circle relatively easily. A tangent makes a right angle with the radius. Well, that's particularly useful because if we can work out the centre of the circle, if we know what that is, I can then work out the tangent at any point on the outside of the circle. Let's say I know this point here. Then I can work out the gradient of the radius there. And then the gradient of the tangent will be the negative reciprocal. And then I can do y equals mx plus c to work out that equation. Or vice versa. I might be told the equation of a tangent at a point, and then I know that the gradient of the radius is going to be the negative reciprocal of that, and so I could work out the equation of this line. And then I know that the centre of the circle is somewhere on that line, so that's going to help me to work out the centre. The Third circle theorem we're going to look at is the radius bisects a chord at a right angle. So that's going to be particularly useful because if I have a chord, let's say I've got the chord AB, then I know that the perpendicular bisector, so the line that goes through the midpoint of that is perpendicular, so perpendicular bisector, I know that that line has to go through the centre somewhere. The centre might be here or here or here. If I know another point on the circumference, let's say I know point C over here, then I could do a similar thing by working out the perpendicular bisector of BC. And then I know that the centre of the circle is on both of those lines, so I could do simultaneous equations to work out the centre there. Right, let's look at 3 specific examples going through what I've just said and using those circle theorems. So, here we're told that the equation of a circle is x minus 2 all squared plus y minus 6 all squared equals 100. And I'm told that the point P, 10, 0, lies on the circle. We need to work out the equation of the tangent at that point. So I know, looking at the equation here, I know that the centre of the circle is 2, 6. So I can then work out the gradient of the radius at this point by doing the change in the y coordinates. So 6 minus 0 divided by the change in the x coordinates. So 2 minus 10. You can see that calculation is there. So I worked out that the gradient of the radius was minus 3 over 4. Now, circle theorems tell me that the gradient of the tangent will be the negative reciprocal of that because they are perpendicular. So the gradient of my tangent is positive 4 over 3. I've then done y equals mx plus c. I know my tangent is going through the point P, so I know that the y coordinate is 0 when the x coordinate is 10. That allowed me to work out that c was minus 40 over 3. And so the equation of my tangent was y equals 4 over 3x minus 40 over 3, which I then just did a little bit of rearranging to get it into the form that the question asked for. Just to show you that diagrammatically, so you can picture what I've just done. You can see the equation of the circle there, where the centre is 2, 6. I've got the point 10, 0 down there. I worked out the gradient of the radius here. I then did the negative reciprocal to get the gradient of my tangent, because I know they're perpendicular. And then I did y equals mx plus c with the point 10, 0. Second example. I've been told that the points A, B, and C lie on a circle. Part A says to prove that triangle ABC is a right angle. So you can see I've just drawn a little sketch down here, just to help me explain this and to help visualise what's going on. What I've done is I've worked out the gradient of AB by doing the change in the y divided by the change in the x. So 7 minus 3 divided by 2 minus 0. And so I worked out that the gradient of AB is 2. The gradient of this line here is 2. I've then done a similar thing with BC. I've worked out the gradients there by doing the change in the y coordinates divided by the change in the x coordinates. And I worked out that the gradient of that line was minus 1/2. All I've done then is I've taken those two gradients and multiplied them together, and I got minus 1. And that's telling me then that AB and BC are perpendicular. They must be at a right angle. Then for part B, it says, hence find the equation of the circle. So the fact that I know I've got a right angle there, and my circle is going to be looking something like this, roughly. The fact that's a right angle, that's telling me that this is definitely a diameter from our circle theorem, because the angle in a semicircle is 90 degrees. So therefore, I know AC is a diameter. Therefore, I know the centre of the circle is the midpoint of AC. So to work out the midpoint of AC, I can add the x coordinates together. So 0 plus 4 divided by 2 is 2. Then add the y coordinates together. So 3 plus 6 divided by 2, which is 4.5. So I know that the midpoint and the centre of my circle is 2, 4.5. I can now work out the radius of the circle. Because I've got the centre, I know point C is 4, 6. So, doing a little bit of Pythagoras here. Looking at the x coordinates, I know that this is 2. Looking at the y coordinates, I know this is 1.5. And so, a little bit of Pythagoras to get the radius. 2 squared plus 1.5 squared, all square rooted, is 2.5, or 5 over 2. So the radius of this circle is 5 over 2. And I can now write down its equation. X minus the 2 plus y minus the 4.5, all squared, equals the radius squared, and we're done. Last example for this video. We're told that the points P and Q lie on a circle with centre C as shown in the diagram. We've been given the coordinates of P and Q. We're told that M is the midpoint of P and Q. And we're told that the line L passes through M and C, which is the centre. So the fact that L is passing through the centre of this circle and it's passing through the midpoint, I know that's a perpendicular bisector of the chord. So I know these are perpendicular. So, what I did to begin with, I worked out the coordinates of point M, because I know it's the midpoint, so I added the x coordinates of P and Q together and then divided by 2. I then added the y coordinates of P and Q together and divided by 2. So I know the coordinates of M are minus 2, minus 3. I've then worked out the gradient of PQ by doing the change in the y coordinates divided by the change in the x coordinates. So I worked out the gradient of PQ was minus 2/5. Remember that I know that L is perpendicular to that. So the gradient of L is the negative reciprocal of minus 2/5. So it would be positive 5 over 2. I've then done y equals mx plus c with the fact that I know it goes through point M, which I worked out before as minus 2, minus 3. And that's allowed me to work out the equation of line L. We've then been told that the y coordinate of the centre of the circle is minus 8. Now I know that the centre of the circle is going through I know this line here goes through the centre of the circle. So if I substitute minus 8 into that, I'm going to be able to work out the x coordinate of the centre of the circle. So that's what I did here. I now know that the centre of the circle is minus 4 minus 8. And I'm now going to use that to help me to get the radius of the circle by doing a little bit of Pythagoras. The change in the x coordinates from minus 4 to 3 is 7. The change in the y coordinates from minus 8 to minus 5, is 3. So 7 squared plus 3 squared, all square rooted, we get root 58. So the radius of the circle is root 58, and I can now say that the equation of my circle is x minus 4, all squared, plus y minus 8, all squared, equals the radius squared. So equals root 58 squared, which is just the square root and the squared will cancel out and I'll just get 58. So that is the equation of that circle.